All right, well, fifth graders, as we're getting into chapter 9 here, which is going to be on multiplying fractions, whole numbers, mixed numbers. So when I write here steps of multiplying fractions, that includes when whole numbers are involved with fractions or when mixed numbers are involved. Uh, as long as there is a fraction or a mixed number involved in the problem, that all fits under this subheading of multiplying fractions. I'm going to need you to pause the video, take a screenshot of this, write it down, memorize it, do something. Because these 4 steps are going to be at the root of everything we're doing here in chapter 9. Chapter 9 has like 8 different lessons, and it's all going to stem from this. Step 1, make everything a fraction. Step 2, cross-check. Step 3, multiply. Step 4, simplify. I'm going to read that again. Steps of multiplying fractions. Number 1, make everything a fraction. Number 2, cross-check. Number 3, multiply. Number 4, simplify. So as you can see, even though this whole chapter is about multiplying fractions, there's a lot more involved to it than just multiplying. Okay? Because you can multiply correctly, but if you're doing the other steps wrong and you're multiplying the numbers that are different than the numbers you're supposed to be multiplying by, you're not going to get the right answer anyway. So each of these 4 steps is critically important in multiplying fractions. So pause, take a screenshot, do whatever you need to do, because I'm going to need this board later on in this same video. So if you haven't paused yet or taken a screenshot, you're going to now need to rewind in order to be able to do that, because now I'm clearing that out. But those steps, make everything a fraction, cross-check, multiply, simplify. So lesson 1 specifically focuses on multiply, write your answer in simplest form. Well, today's lesson for 9.1 focuses on taking whole numbers and multiplying them by fractions. Okay? When I take a whole number and turn it to a fraction, I simply put it as over 1. The idea is a fraction is just a fancy way of writing a division problem. That is something, 5th graders, that you're going to get used to hearing me say, something that I want you to understand, that a fraction is just a fancy way of writing a division problem. And this essentially is 3 divided by 1. This is 9 divided by 10. Even though we're not really going to be thinking about division, you're going to get to the point in your math lives where it's just going to be expected for you to understand that when you see a fraction, it means you're dividing. So this is 3 divided by 1. This is 9 divided by 10. All right? And then you're going to cross-check. And I'm not going to do this on every problem, but I will do it on the first couple. When I cross-check, which is step 2, so once again, anytime you want to take a whole number like 3 and make it a fraction, you just put it over 1. 3 divided by 1 is 3. When I cross-check, I kind of make a little cross here as an X, and it's not necessary to circle them like this, but I'm doing this just to show you. You're partnering up the 3 and the 10, and you're partnering up the 1 and the 9. All right, and you're basically asking yourself this same idea of simplest form. Is there a number other than 1 that can go into both 3 and 10? Is there a number other than 1 that can go into both 1 and 9? Now, a common mistake is, well, as long as the smaller number can go into the bigger number, then you can do that. Well, you can, but it's not the smaller number going into the bigger number. It's just essentially if there is a number other than 1 that can go into both. So I'm thinking about 1 and 9. I'm not going to be able to make 1 any lower, so there is not a number other than 1 that can go into both 1 and 9. Those cannot be changed. There is not a number other than 1 that can go into both 10 and 3. So those cannot be changed. So now it's just time to go ahead and multiply. Well, so that's step 3. Sometimes I can't cross-check, and the point of cross-checking is to make the numbers smaller when I multiply, which gives me a smaller number here. As you've heard Mr. Swack say before, when it comes to things like this, when fractions, the smaller numbers you work with, the easier it is. It's less likely that you're going to make a mistake with smaller numbers. But here I can't make them any smaller. If you can't cross-check, then you know your answer is going to be in simplest form. So the only thing you might have to do is take an improper fraction and turn it into a mixed number. So when I'm looking at this here, and I'm thinking, well, okay, there's no number besides 1 that can go into both 3 and 10. No number besides 1 that can go into both 1 and 9, so I can't simplify. So when I multiply, I just multiply the numerators, 3 times 9. 3 times 9 is 27. Then I do the denominators, 1 times 10. Well, 1 times 10 is 10. Well, now I have an improper fraction, and it's in simplest form, as I knew it would be. No number besides 1 can go into both 27 and 10. But when I turn an improper fraction into a mixed number, remember what this is. This is a division problem. Well, 10 can go into 27 2 times. And if I take 10 into 27 2 times, there will be 7 left over. All right? And there will be 7 left over. My denominator here is 10, which means my denominator there is 10. I get 2 7/10. All right? So let's look at this next one. 4 times 5 over 8. Well, once again, step 1, make sure everything's a fraction. So my 4 is going to become 4 over 1. So now I'm thinking about cross-checking. Well, there's no number besides 1 that can go into both 1 and 5. So it's always matched up that way. You can't just match up however you want when you cross-check. It always has to be this way that I showed it circled. There's no other option when it comes to cross-checking. No number besides 1 can go into both 1 and 5. However, 4 and 8, I'm thinking, well, they're both divisible by 2. Now, 2 would work, but actually the best number to use is 4, because the bigger number I divide them by, if I make these numbers as small as they can possibly be, it's going to be in simplest form. If I only divide it by 2, this becomes a 2, because 4 divided by 2 is 2, and 8 divided by 2 is 4. But they're also both divisible by 4. So 4 divided by 4 is 1, and 8 divided by 4 is 2. I made the numbers just a little bit smaller, which makes it easier to work with. Now I multiply 1 times 5. 1 times 5 is 5. Then I do 1 times 2. 1 times 2 is 2. Well, now I got 5 over 2. 5 divided by 2. Well, 2 can go into 5 2 times. If I take 2 into 5 twice, there's 1 left over. My denominator here is 2. So my denominator there is 2. I get 2.5. All right? 6 times 35 over 100. Sometimes you're going to get some bigger numbers. Okay? Well, same thing though. 6 becomes 6 over 1, and I can't cross-check a 1 and a 35. Nothing besides 1 can go into both 1 and 35. But I can think about 6 over 100. Okay? Well, I see that this is an even number and that is an even number, so they're both divisible by 2. Well, 6 divided by 2 is 3. 100 divided by 2. 10 divided by 2 is 5. I add the 0, I get 50. All right, so I get 3 over 50. There's nothing besides 1 that can go into both 3 and 50. So I'm going to do 1 times 50, and that's 50. When you get bigger numbers like this, which won't happen too often, but once in a while, you may have to come over here to the side and just do 35 times 3, but you know how to do that, 5th graders. 3 times 5 is 15. Put the 5 down, carry the 1. 3 times 3 is 9, plus 1 is 10. I get 105. Okay, so I get 105. Okay, now I'm thinking, okay, well, how many times can 50 go into 105? Well, I know that 50 times 2 is 100. So I'm going to say that 50 can go into 105 twice. There's going to be 5 left over because there's a difference of 5 between 100 and 105, and 50. Now, this is an example of a problem as to why you always make sure it's in simplest form. Because you'll remember what Mr. Swack said. I said, well, if you've made the numbers as small as you can, it's going to be in simplest form. Well, we did. We can't cross-check anymore a 1 and a 35 or a 3 or a 50. So why all of a sudden do I have a fraction here that's not in simplest form? And I know that this is not in simplest form because this is 5 and that ends in 0, which means they're both divisible by 5. Well, the reason why that's not in simplest form and the reason why we always include step 4, because number one, you may accidentally not divide by the biggest possible number. You may forget to cross-check, so you always check. But in this particular problem, this fraction right here, 35 over 50, is not in simplest form. All right? Even though I can't make the numbers any smaller, this number is not in simplest form. So something that you can do, now I don't typically do this, but you can, if you notice that one of the fractions is not in simplest form at the beginning of the problem, feel free to go ahead and simplify it. As long as you simplify it correctly, it will still be the same answer. So you get 35 over 50. All right, and if I was to simplify that, it'd be 7 over 10, because I could divide them both by 5, and 35 divided by 5 is 7. 50 divided by 5 is 10. And I get 2 and 5 over 50. Well, I see both of these are divisible by 5. 5 divided by 5 is 1. 50 divided by 5 is 10. So I see that this is going to work out to be 2 and 1 over 10. And that's my answer in simplest form. That's why you always make sure that things are simplified. Well, 4 over 5 times 15. Now, the whole number does not always come first. So we got 4 over 5 times 15 over 1. And once again, I'm going to cross-check. Nothing besides 1 can go into both 4 and 1. However, I've got 5 and 15, and I think 5 and 15 are both divisible by 5. 5 divided by 5 is 1. 15 divided by 5 is 3. So now I go ahead and multiply. 4 times 3 is 12. 1 times 1 is 1. I get 12 over 1, and I know that 12 over 1 is just 12. 12 divided by 1 is 12. Last one before we talk about the second part, 7 times 11 over 8. Well, my 7 is going to become 7 over 1, okay? And so I'm thinking about cross-checking. Nothing besides 1 can go into both 7 and 8. Nothing besides 1 can go into both 1 and 11. So I cannot make those any smaller. So I'm thinking, well, 7 times 11. 7 times 11 is 77. And 1 times 8 is 8. All right. And I've got 77 now divided by 8. Well, 8 can go into 77 9 times. If I'm thinking about my times tables, and I'll just put another plug in here, 5th graders. As you often hear me say, fractions are the premier prime example of why it's important to know your multiplication tables. If you know your multiplication and division facts very well, fractions are going to be so much easier. Well, 8 can go into 77 9 times. If I take 8 into 77 9 times, there's going to be 5 left over, because I know that 9 times 8 is 72, and if I take 72 away from 77, I get 5. 5 over 8. Nothing besides 1 can go into both 5 and 8, so I know that 9 and 5/8 is in simplest form. And so remember, when you're simplifying fractions and it's a mixed number, that whole number doesn't matter. It's only the only numbers that are changing are the numerator and denominator parts of the fraction. All right, now, the second part of what you're doing today is going to tell you these instructions. And I don't have these written out yet because I had my steps written there. But it's going to tell you to find the unknown number. Okay? Find the unknown number. Okay, I kind of move my foot around there. Let's kind of clean that up. Find the unknown number. Well, so you're going to get something that looks like this, all right? It might say, and we're just going to look at a couple of examples, blank times 3 over 10 equals 9 over 10. or it might say blank times, I don't know, let's go 8 over 9 equals 32 over 9. All right, so there's an interesting situation. All right, blank times 3 over 10 equals 9 over 10. Well, remember, when it's a multiplication equation, what I'm going to do is I'm essentially going to divide these two numbers, okay? And it's basically going to be, okay, 10 divided by 10, which is 1, so I can kind of think 1, and then 9 divided by 3, which is 3. So I end up with an answer of 3 over 1, okay? Which means that really all you're doing is the 9 divided by 3. And 9 divided by 3 is 3. And that's all you need to put there. Now, once again, if I look at this one, I can think 9 divided by 9, and that gives me 1. However, I'm going to tell you, I really don't want you thinking about that. Because when we get into division of fractions, okay, in the future, you do something completely different. But it works here because all your examples, these are going to be the same denominator. So you get away with that here. It's just a way to think about it. But really all you're doing is the 32 divided by 8. 32 divided by 8 is 4, and 4 over 1 is 4. The idea is that 4 times 8 over 9 equals 32 over 9. Because if you thought about it and you made that 4 over 1, well, 4 times 8 is 32. 1 times 9 is 9. Just like in this one, if you made the 3 and made it 3 over 1, 3 times 3 is 9. 1 times 10 is 10. All right, so that's introduction to multiplying fractions and whole numbers. All right, we'll talk to you later, 5th grade. Bye.